most teams still talk about AI agents like they are just chatbots with better branding. That sounds small, but it creates a real problem. If you confuse a system that talks with a system that executes, you end up designing automation that looks impressive in a demo and does almost nothing in production. A chatbot gives you advice. An agent is supposed to help produce outcomes. That is the difference this video is about. The tricky part is that both can look similar at first. Both might use the same model. Both might sit behind a chat box. Both might answer in polished language. But the actual question is not, can this system explain the work? The question is, can it move the work forward safely? That distinction matters in cybersecurity because advice is cheap and outcomes are expensive. It is easy to generate a summary of a vulnerability. It is harder to connect that summary to the affected asset, the business owner, the exploit context, the maintenance window, the ticketing system, and the approval process. That is where the word agent either becomes real or becomes marketing. If I ask a chatbot how to handle a vulnerability, it can explain the steps. It can summarize the CVE. It can suggest priority. It can even write a good remediation checklist that can be useful, but nothing has actually changed yet. No findings were pulled. No affected assets were grouped. No remediation ticket was opened. No approval gate was checked. No patch window was scheduled. The system talked, but it did not operate. This does not make chatbots bad. A good chatbot can be a very useful analyst assistant. It can help you reason through a confusing issue, rewrite messy notes, compare options, or explain why a control matters. That is valuable work. But you should not confuse explanation with execution. If the only output is text on a screen, the burden still falls back on a human to copy the answer, check the data, open the right system, create the ticket, assign the owner, set the due date, and track the result. The chatbot can reduce thinking time, but it has not changed the operational state of the environment. An agent is different because the system is designed around state change. It has a job of process, tools, and boundaries. It is not just answering the question. It is trying to advance a workflow. A real agent needs three things. First, it needs a plan, not a giant philosophical plan, just a concrete sequence like collect findings, enrich them with asset context, compare them against exploit intelligence, prioritize the queue, and prepare the next approved action. Second, it needs tools. That means it can actually read scanner output, query asset metadata, check whether an issue is internet facing, and draft work in the right place. Third, it needs action, not reckless action, controlled action inside a policy boundary. Those three pieces work together. A plan without tools becomes a checklist. Tools without a plan become random automation. Action without controls becomes risk. The agent pattern is useful only when all three are present. For a security team, this usually means the agent does not start by asking, what do you want to talk about today? It starts with a defined mission. For example, review new critical findings, enrich them, decide which ones need immediate attention, and prepare the next human reviewable step. That mission has inputs, allowed tools, expected outputs, and stop conditions. The stop condition is important. A mature agent should know where it is allowed to proceed and where it must pause for review. That is, what separates useful operational autonomy from an uncontrolled script with a language model attached. That is the part many teams skip. They build a chat interface, add retrieval, maybe let it answer with confidence, and then call it an agent. But if the system cannot move work forward in a controlled way, it is still mostly a chatbot. The cleanest way to see the difference is through vulnerability management. Imagine a scanner drops a new batch of findings. A chatbot can answer questions about those findings all day long. Which ones are critical? What does this CV mean? How do I patch it? That helps the analyst, but the analyst is still doing the workflow by hand. They still need to figure out which assets are real production assets, which ones are duplicates, which ones are internet facing, which ones already have tickets, and which ones can wait. Now compare that to an agent workflow. The agent starts by ingesting the findings. It checks the scanner output against an asset inventory. It looks for ownership data. It checks whether the affected host is in production, staging, development, or a user workstation. It looks at exposure. It checks whether threat intelligence says the vulnerability is actively exploited. The difference is not just intelligence. The difference is connection. The agent is connected to the work system. It can carry context from one step to the next instead of leaving the human to stitch everything together manually. An agent workflow starts somewhere else, ingests the scanner results, it maps each finding to a real asset, it checks business criticality, it checks whether the asset is exposed to the internet, it looks for a known exploited status, or current threat activity. It checks whether a maintenance window already exists. It groups duplicates so 3 scanners do not become 3 copies of the same task. Then it produces a prioritized queue. Now we are moving from conversation to alt behaves. This is where agent design starts to feel practical. The system is not trying to replace the entire information behaves security team. It is taking the repetitive coordination work and turning it into a consistent workflow. That matters, behaves, because vulnerability management is rarely blocked by lack of information. It is blocked by messy context, unclear ownership, duplicated findings, and too many handoffs. Behaves. A good agent can reduce that friction. It can say these 5 findings all map to the same service. This service is internet facing. This owner is listed in the inventory. This exploit signal raises urgency. Automation behaves. This maintenance window exists tomorrow night. Here's the recommended priority. Here's the evidence. And here is the proposed ticket. Automation behaves. That is a different level of usefulness than a paragraph explaining the vulnerability. It gives the human a prepared decision instead of a blank page. Here is a simple example. Say the scanner finds a critical authentication bypass on an internet-facing VP gateway. It also finds a high-severity web framework on an internal staging app, and it finds a medium-severity library problem on a workstation used by finance. Behave. A chatbot can explain all 3. An agent should rank them, attach evidence, create the correct remediation task, and route the riskiest item into an approval path for accelerated handling. Because the VPN gateway should probably rise to the top because exposure changes the story. If automation behaves interfacing, tied to remote access, and connected to active exploitation, that is not just a vulnerability. Behaves, that is an access risk. The agent should collect the relevant evidence, identify the owner, draft the ticket, behaves, and prepare an approval package for remediation. Automation behaves. The staging app might still matter, but the context is different. Maybe it is internal behind a restricted behaves network and currently under a patch freeze because a release is in progress. The right action might be automation behaves to open a ticket, link the finding to the next release window, and mark it for follow-up. It behaves. The finance workstation is different again. Maybe it needs endpoint patching, user coordination, or a standard device management. Automation B workflow. One scanner severity number does not tell you all of that. The agent becomes useful when it understands the operational path for each case. That routing logic matters because in real environments, priority is not just CVSIS. It is exposure, asset criticality, exploit activity, and operational context. Automation behaves. Maybe the VPN gateway is internet-facing, tagged critical, and linked to a live exploit bulletin. Automation behaves. That should not wait in the same queue as an internal development system with a patch freeze, and behaves no active exploitation. The agent can detect that pattern faster than a person paging through 3 dashboards. The important part is not just speed, it is traceability. Automation behave. If the agent creates a priority score, it should show the ingredients. Did the score increase because on how the automation behaves? Asset was internet facing. Did it increase because the exploit is known to be used in the wild? Did it increase because the asset supports authentication, finance, customer data, or remote access? Did it decrease because the automation behaves the system was isolated, temporary, or already scheduled for retirement? This matters because security teams need reviewable decisions. If a human disagrees with the agent, they need to automation behave, see why it ranked something higher, otherwise the agent becomes another mysterious scoring system that people ignore. Automation behaves. A trustworthy agent should not just say this is urgent. It should say this is urgent because of, and that behaves these findings, this asset record, this exposure flag, this threat note, and this policy rule. That is how automation earns trust. Automation behaves. The agent should show why it made the decision, which finding IDs drove the ranking, which asset record behaves have confirmed exposure, which threat note raised urgency, which policy required human approval before a production change. Automation B is without that evidence chain, you do not have a trustworthy agent, you have a black box with good behaves. This is also why controls matter. A real agent is not just a more capable conversation loop, but a controlled execution system. Think about the approval gate. In a weak design, the agent might say this is critical, and how the automation behaves, I'm going to patch it. That sounds powerful, but in production it is dangerous. You might break a behave system, violate change control rules, or patch during a business critical window. Automation behaves. In a stronger design, the agent does the safe parts automatically. It gathers evidence, it deduplicates the findings, remediate, creates the proposed remediation task, it identifies the owner, prepares the change request, then it stops and asks for approval before the risky action. That pause is not a failure of autonomy. It is the point. Most useful agents in security will behave in this middle zone. They will automate the repetitive evidence heavy work while keeping humans in control of decisions. In our vulnerability warrior flow, the agent can safely normalize findings, enrich context, calculate a priority score, draft remediation. That behaves tickets and prepare an approval packet, but it should not silently push a risky patch into production just because the model sounds confident. Automation behaves, so the workflow becomes detect, make, prioritize, prepare, and then hand off through an approval gate. That last, we have step is not a weakness. That is what makes the system operational. The useful pattern is partial autonomy with strong boundaries. Automation behaves. This is also where teams should think about logs, retrace, and failure modes. What happens if the scanner automation behaves? Me asset IDs. What happens if the asset inventory is stale? What happens if threat intelligence is unavailable? What happens if the ticketing tool returns an error? A chatbot usually does not need to answer those operational questions. An agent does. If it is part automation behaves of a workflow, it needs to fail safely. It should mark uncertain data as uncertain. It should avoid and how the automation is inventing missing context. It should create a review item when confidence is low. It should keep an audit, behaves, trail of what it read, what it changed, and what it recommended. That is why real agent work feels less like prompt engineering and more like system design. The model is only one component. The rest is process tool access, permissions, observability, and human control. And the common mistake is believing that better language output equals better automation. It does not. A polished answer, how the automation behaves, is still an answer. If the system only tells you what should happen next, it is advice. The automation behaves, it actually performs the safe parts of the workflow and packages the risky parts for review. That starts to look like an agent. Automation behaves. So here is the test. Can the system plan the work? Can it use the right tool? Automation behaves. It take meaningful action inside clear controls. Can it explain its evidence? Can it stop when the next step requires judgment, authority, or business context? Behaves. If yes, you are getting close to a real agent. If no, you probably have a useful chatbot. All automation behave. Just do not design your process as if advice and outcomes are the same. Automation behaves. For cybersecurity, this distinction is going to matter more over time. The teams that win with AI. Automation behaves. Agents will not be the teams with the flashiest chat interface. They will be the teams that connect the automation behaves models to reliable workflows, constrain them with policy, and make the work reviewable. Automate is the real shift, not chatbots that sound smarter, systems that help work move from finding to context to decision to controlled action. Behaves. If you want more practical AI agent workflows for security and automation, subscribe. In the next videos, automation behaves, we will keep breaking down what production agents actually need, failure modes, drift, testing, maintenance, and human control execution.